Okay, we have here something interesting today. I want to find the value for the digamma function at minus 1/3 using particularly these formulas on the right. And I'm going to assume I don't know any other digamma values except for just one. We'll assume we know that that one is going to be minus the Euler-Mascheroni constant, which is around 5.77. And also I'm going to try to pick up some other values along the way, because you could do like Gauss's digamma theorem and go directly to this value, even though it's still probably long because it's a long formula, but that might be a nice way. And you might be able to do it kind of more direct than what I'm going to do. But what I'm going to do is, in the process, I also want to get a value for digamma of 1/3 and digamma of 2/3. And I think what I'll do is start with the reflection formula right here with these two values, because you'll just notice that when you add 1/3 and 2/3, you get 1. The same thing as when you add 1 minus z to z, you also get 1. So let me actually shuffle this, even though we could leave it. I just kind of like it the other way. So let's write it as, we'll start with digamma of 2/3 minus digamma of 1/3 equals pi cotangent pi of z. So for this, we're starting with our z as 1/3. So we want cotangent pi of 1/3, or pi over 3. But cotangent pi over 3 is going to be 1 over square root of 3. So what we have for this equation is pi over square root of 3. But then just notice I really haven't found anything yet, because I don't know either of these. So we basically have one equation and two unknowns. It's like when you've got a plus b equals 3. What do we have? We don't know. What do we have? We've got an infinite number of solutions. We can't say yet. So that's where we're going to bring in this other formula right here. Now for this one, I found what works well on it is if we set our n value equal to 3 and our z value equal to 1/3. That way, you multiply 3 times a third, you get 1, but we already know that value. So that sets it up pretty nicely. So what's going to happen, on the left side of our equation, we'll have digamma of 1. Then everything we just plug in, so our n's 3, so we're going to have 1/3. Sum from 3 minus 1, so our upper part is going to be 2. We're going from k equals 0 to 2. Digamma of our z, which is 1/3 plus k over 3. And then ln of n is going to be just ln 3. I'll multiply both sides by a 3 just in order to clear this right here. So this will like cancel with this, and I can put it in front of the ln right here. On the left side, we'll use this value. So this becomes minus 3 Euler-Mascheroni constant. Then let's expand out this sum. So when k is 0, we have digamma 1/3. And then for the next term, k is 1, we're going to end up with digamma 2/3. And when k is 2, we end up with digamma of 1. But let's just plug this thing in. And then on the end, we got plus 3 ln 3. And I'll just rearrange the equation a little bit. We'll write it, we'll get this stuff on the left side. So we'll say digamma 1/3 plus digamma 2/3. When I move this on the other side, this becomes minus 2 Euler-Mascheroni constant, and this is minus 3 ln 3. So now I've got the two equations I want to work with. We've got this one up top and this one right here. Let me clean up the board and let's see if we can put it together now. Now we've got two equations and now we have two equations and two unknowns, so we should be able to solve for each of these values. Okay, now from here what I want to do is let's just add these two equations together, because digamma 1/3 is going to cancel. And so we have two copies of this, digamma 2/3. Add up the right sides of the equation. And then all I need to do to get our digamma 2/3 value is let's divide by 2 on both sides. And so for digamma of 2/3, we get pi over 2 square root of 3 minus Euler-Mascheroni constant minus 3/2 ln 3. And that's our value we want right there. And so next, in order to get our value for digamma 1/3, let's subtract these two. Although I really want to do it the other way. I don't want to subtract down. Let's subtract off this one just so we get the sign right. So when I do that, the digamma 2/3 will cancel out. We end up with 2 digamma 1/3. Then we're going to have this minus 2 Euler-Mascheroni constant minus 3 ln 3. Then I need to subtract out this pi over square root of 3. Again, divide by 2 on both sides. This cancels. And so for digamma 1/3, we're left with minus Euler-Mascheroni constant minus 3 over 2, ln 3 minus pi over 2 square root of 3. And that's our value for digamma 1/3. You'll notice it's really similar to our value for digamma 2/3. It shouldn't be too surprising based on the way this works because you're breaking it. Because by subtracting, we basically just did this, and this is pretty simple. Okay, one last thing. So I want to get a value for digamma minus 1/3. What we can do for that one, we can just use this equation right here. And actually what I can do is just rearrange it a little bit. Just subtracting off the 1 over z on both sides, we can write this as digamma of z equal to digamma z plus 1 minus 1 over z. So if I want a value for digamma minus 1/3 over here, we just need to add 1 to this and we get digamma of 2/3 and then minus 1 over z. So 1 over z is going to be minus 3. Minus times minus is going to be plus 3. So for our value, digamma minus 1/3, we just need digamma 2/3, which is all this, and then just add a plus 3 to it, and that's it. So as you can see, the recursion formula is the easy one to use. And once we had these values, it's very easy to get to digamma minus 1/3. Actually, basically you could do the same kind of thing. Like if you wanted to, going up or down by 1 is no problem. Like if you wanted to add 1 here and get digamma of 4/3 or digamma of 6/3, no, not 6/3, because that's 2, but like digamma of 5/3 or 19/3 or, well, actually for digamma of 19/3, you'd have to use the formula like 10 times or whatever. But otherwise, the formula there is pretty easy to use. So that's it for today. Thanks everyone for watching. Have a good day.